Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR June 2023, paper 4, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. Calculate the square root of 5.2 squared minus 4.8 times negative 6.3. Okay, so I'm just going to carefully type that into the calculator. I'm going to put the square root sign. Make sure everything it goes underneath the square root. The line goes all the way across when you're doing this. So 5.2 squared minus, well, I've got two minus signs, so those I'm just going to change that in my head. I'm going to minus is a plus, so I'm going to do 5.2 squared plus 4.8 times 6.3. Okay, and then that comes out to be 7.568 and change. So I'm going to round off to three significant figures. So the 7.568 is going to round up to 7.57. Now this is a 2-mark question, so probably if you just want to play it safe, you're not sure about rounding, just write the whole number down first. That would be enough to secure you the first mark, whatever your display is on your calculator, and then if you round it off incorrectly, you're still going to get one of the 2 marks. Okay, so yeah, just a bit of a top tip to bank a mark along the way. Question 2. The price of petrol decreases from £1.32p per litre to £1.2p per litre. Calculate the percentage decrease in the price. Okay, now I like to do percentages with this little triangle, final, original, multiplier. So I try and identify which is which from the question. So what is the final price here? It's going to go from £1.32 to £1.2, so that's the final price, 1.02. The original price is that one there. Okay, so that's going to go here. Original is 1.32, and the multiplier, that's what we're trying to find, isn't it? I'm trying to find the percentage decrease, so the multiplier is the thing essentially that I want to find. Okay, so that's the one I want. So covering that thing that you want to find, it tells you what to do with the other two. Just works the same way as a DST triangle if you've used one of those. So multiplier is equal to the final divided by the original. In this case, the final is 1.02 and the original is 1.32. So tapping that into the calculator, 1.02 divided by 1.32. That gives me 0.7727. I'm going to round it off to 0.773. Okay, now that's a decimal. If I want it as a percentage, I'm going to have to times it through by 100. That's 77.3%. Okay, and then we need to interpret this as a percentage decrease. Okay, now if you started off with 100% and you've now got 77.3%, then that is a decrease. What would you have to take away from 100 to get 77.3? You'd have to take away 22.7%. So that's my final answer, 22.7%. Question 3a. Eve, Jack and Ling share some money in the ratio of 2 to 3 to 4. Jack gets £720. Work out how much Ling gets. Okay, so we've got Eve, Jack and Ling in the ratio of 2 to 3 to 4. And we know that Jack, which is the middle column, gets 720. We want to know what Ling gets. Okay, so if you have a think about what you need to multiply 3 by to get 720, that's just 720 divided by 3, which is 240. I'd have to multiply that by 240 to change 3 into 720. Now if I do that to Jack, I have to do that to Ling and Eve as well. So 4 times 240 is 960, and just for completion, this one is going to be 480, although I don't really need it because I just need to work out how much Ling gets, and how much Ling gets is that one there, isn't it? She's going to get 960, or he's going to get 960. Not sure if it's a boy name or a girl name. 960. Part B. Amir, Beth and Casey share some money in the ratio 3 to 5 to C. Casey's share is 2/3 of the total. Find the value of C. If you have a look at Amir and Beth's share, we've got Amir to Beth to Casey in the ratio of 3 to 5 to C. Then if we know that Casey's share is 2/3 of the total, then those two parts then are going to have to be the remainder. It's going to be 1/3. Okay, so Amir and Beth have got 3 shares and 5 shares each. So 3 plus 5 is equal to 8 shares. And 8 shares is going to be worth 1/3 then, isn't it, of the entire amount. Okay, so then if you times that by 3, then 24 shares is the total. And so C is going to be 24 times 2/3. It's going to be 2/3 of that, isn't it? Or it's going to be twice 8 shares, I guess. It's going to be 16. Okay, anyway, C is 16. Question 4. Alex invests £4,500 at a rate of 7.5% per year, simple interest. Find the value of the investment at the end of 4 years. Okay, so final, original, multiplier. What's what here then? Okay, well, the final is what we want to try and find at the end of 4 years. Find the value of investment after the end of 4 years. That's the final. That's the one we want to find. Original is the amount that we started with. So that is 4,500. And the multiplier, well, we've got a 7.5% a year simple interest. Okay, now simple interest means that you just apply that 7.5% interest repeatedly that amount of time. So if we're going to do it for 4 years, then our multiplier is going to be 100% what we started with, plus 4 lots of the simple interest rate of 7.5%. Okay, so 4 lots of 7.5, what's that? 7.5, 15, 30 plus 100, that's 130%. Okay, so cover up the thing I want to find. I want to find the final. That tells me the final is the original times the multiplier. Final equals original multiplied by multiplier. I use this triangle for every percentage question if you haven't noticed. Very handy. So 4,500 times 130% as a multiplier is 1.3, isn't it? That's what? 130% is a decimal. So 4,500 times by 1.3, that comes out to be 5,850. Okay, that's my final answer, isn't it? 5,850. Right, now at the end of 2 years, the value of the investment is over 13,500 for the first time. Find the value of T. So starting out the same way with my triangle, final, original, multiplier. This time we actually know what the final is. It's 13,500. We know what the original is. It's still 4,500. So that came from there. Look. That still came from the green bit at the top. And then this time the multiplier is, it's going to be T years at 7.5% per year. So that is going to be a multiplier of 100% plus 7.5T then, isn't it? because you're going to multiply t by 7.5. That as a decimal would be 1 plus 0.075 t. Okay, so then I'm going to arrange this in terms of m, because it's part of the multiplier. I don't know, it's the time, I don't know. So I'm going to write m as a subject, so multiplier is equal to final over original, which is equal to 1 plus 0.075 t, and that's going to be equal to 13,500 divided by 4,500. Right, what's 13,500 divided by 4,500? That comes out to be 3. So I've got 1 plus 0.075 t is equal to 3. Take 1 away from both sides. Going to get 0.075 t is equal to 2. And then times in, also dividing both sides by 0.075. I was going to get a teeny tiny number. So I'm going to do 2 divided by 0.075. And that comes out to be 26 and 6 reoccurring, or 26 and 2/3. So t is equal to 26 and 2/3. So presumably it kind of it goes over that amount between the 26th and the 27th year. So I'm going to round that up to 27, because on the 26th year it isn't going to have gone over 13,500. So it will be at the end of the 27th year that it will go over. Okay, so I'm going to make t equal to 27, rounding that up. Okay, so 27 years. Question 5, write 0.00385 in standard form. Now with these very small numbers in standard form, what you need to do is you take the digit part, the bit that isn't all zeros, and rewrite that as a number between 1 and 10. So I'm going to rewrite that as 3.86. So the same digits that I've got the detail of number at the end. And then you can count these number of zeros at the front. So 1, 2, 3. I've got 3 zeros in front of 386. That means I'm going to have times 10 to the minus 3 then as my answer. So however many zeros you've got, that's the power of negative whatever you're going to have there. Okay. Part B says the speed of sound is 3.43 times 10 to the minus 1 kilometers per second. An object is traveling at the speed of sound. Work out how far the object travels in one day. Okay. Now, so I've got the speed of sound written in as 3.43 times 10 to the minus 1. Okay, and what I need to do is multiply that up, because that's in kilometers per second. So if I want to change that into kilometers per day, I'm going to have to multiply through that by however many multiples of that I need to turn seconds into days. Okay, so the distance is going to be equal to the speed of sound times by, well, there are 60 seconds in a minute, there are 60 minutes in an hour, and there are 24 hours in a day. Okay, so I'm just going to type the number in standard form to start with. So I've got 3.43. I'm going to press the exponent key down here and put in the power, minus 1. And then I'm going to multiply that by 60 times 60 times 24. Okay, that comes out to be 29,635.2. Okay, so that's the answer then, isn't it? 29,635.2 kilometers in a day. Okay, now it doesn't say if it wants it in standard form or otherwise, so I guess that's an acceptable answer. Part C says, in a science fiction story, a spacecraft travelling faster than the speed of light is said to be travelling at warp n, where n is an integer. Warp n is defined as n cubed times the speed of light. In the story, a spacecraft needs to travel from Earth to Neptune in less than 2 minutes. The speed of light is 3.00 times 10 to the 5 kilometers per second. The distance from Earth to Neptune is 4.41 times 10 to the 9 kilometers, find the smallest possible warp n at which the spacecraft can travel. You must show your working. Okay, so this is essentially a distance, speed, time question, dressed up rather nicely in a story. Any Trekkies out there? Sounds a bit Star Trek to me. Distance, speed, time. Okay, what have we got? So we've got the speed of light, which is part of the speed, isn't it? So we're not going to use that yet. We've got the distance from Earth. We've got that as 4.41 times 10 to the 9. So that's my distance that we need to travel. So that is the distance, goes here. So we're going to go 4.41 times 10 to the 9 kilometers. What else do we know? We know the time. We know the time has to be less than 2 minutes. Okay, so t, I guess we'll make it equal to 2 minutes, and in a minute we can say it has to be less than whatever that is. Okay, so if t is equal to 2 minutes, then I've got what's that in seconds, because the speed of light is in kilometers per second. So I'm going to rewrite that in seconds. So 2 minutes, which is equal to times 60, is going to be 120 seconds, isn't it? Okay, so if we can then work out the speed that we require to go in order to reach Jupiter in 2 minutes, then, so need to work out the speed. So covering up speed, speed is equal to distance divided by time. See, it's the same method as the percentage one I was doing earlier, isn't it, essentially? Right, so that's distance, 4.41 times 10 to the 9 divided by 120. Okay, so 4.41 exponent key 9 divided by 120. That comes out to, on my calculator, is 36,750,000. Okay, and so warp n is n cubed times the speed of light. So if we take that and divide by the speed of light, then we'll know what n needs to be then. So n cubed times the speed of light, which is 3.00 times 10 to the 5, has got to be equal or less than or equal to, I guess. No, it's got to be greater than or equal to, isn't it? Because it needs to exceed that speed, or equal or exceed that speed to get there in less than 2 minutes. That's got to be greater than or equal to 36,750,000. Okay, so then to find n cubed, we're going to have to divide then that 36,750,000 by the speed of light. So dividing 36,750,000 by 3 exp 5, that comes out to be 122.5. 122.5. Okay, so then if n is a whole number, as an integer, it does say n is an integer up here. So which whole number, which integer has a cube which is slightly more than 122? Well, I know that 5 cubed is 125, so therefore n is going to have to be greater than equal to 5, I guess, then, isn't it? Okay, because it can't be not a decimal, so I'm going to say it's going to be equal to 5. Question 6. A 6-sided numbered spinner is thrown 50 times and the score for each throw is recorded. Some of the results are shown in the table. An 8 was thrown f times. An unknown number on the spinner is represented by n. Okay, the mean score of 50 throws was 5.5. Find the value of f and the value of n. Okay. Well, the value of f is fairly straightforward because we've got a total at the bottom there, haven't we? We've got a total of 50. So presumably then all of these numbers down here are going to have to add up to 50. So if I take what they do add up to away from 50, I'll be left with f. Okay. So given that 12 plus 2 plus 9 plus 16 plus f plus 4 is equal to 50, then those numbers added up, 12 plus 2 plus 9 plus 16 plus 4, that adds up to 43. So f plus 43 is equal to 50, and therefore f is going to be 7, isn't it? So that's 7 in there. Okay, so I know that's 7. Now I know how many of each they've got. I can go on and find an estimated mean, I guess. Well, not an estimated mean, the actual mean, because they're all the precise scores. So to find the mean, I need to multiply all these together, add them up, and divide by 50. So I need to multiply these all together, add them up, and divide by the total of the frequencies, which is 50. So 1 times 12 is 12, 3 2s are 6, 5 9s are 45, 6 16ths, what's that, 80, 96, 8 f's, oh, we know that f is 7 now, so that's going to be 56, and I've got 4n, and I know that adds up to, well, I don't know what that adds up to, I know, well, I do, I know what the mean score is, so we can use that in a sec. So anyway, let's just add that up then. So I've got 12, 6, 45, 96, 56, what's that add up to? So 12 plus 6 plus 45 plus 96 plus 56, that comes to 215. So I've got 215 plus 4n as the total. Okay, now to find a mean, the mean is going to be the sum of the f times x values divided by the sum of the f values. So the sum of the x values that we found, that's this sum here, isn't it? So the 215 plus 4n, 215 plus 4n. The sum of the frequencies, that was 50, wasn't it? So I'm going to put 50 in there. And we know the mean. Mean was given as 5.5. So that goes there then, doesn't it? So 5.5. Okay, so we've got an equation in n here that we can rearrange and solve for n. So multiplying both sides through by 50, 5.5 times 50, that comes to 275. So 275 equals 215 plus 4n. Taking 215 away from both sides, so we times that by 50. Now we're subtracting 275. No, we're not. Now we're subtracting 215 from both sides. That leaves me with 60 on the left, doesn't it? 275 minus 215 is 60, so that must be 4n. So then dividing through by 4, what's that? 4's into 60 go 15 times, so n is going to be equal to 15. Okay? So we've got f is 7, and we've got n is 15. Question 7, here is a table of values for y equals 6 over x minus 2x. Okay, so they've already found all the values for us. That's nice of them, isn't it? So we just need to plot these points. So minus 4 goes with 6.5. Minus 4 goes with 6.5, which is there. Minus 3 goes with 4. There. Minus 2 goes with 1. Minus 1 goes with minus 4. 1 goes with 4. 2 goes with minus 1. 3 goes with minus 4. And 4 goes with minus 6.5. So there. Okay, a very strange looking graph. Okay, now notice that it's not defined at 0. That usually means that that's a undefined point. It's like an asymptote. So this is where the graph kind of shoots off to infinity. Okay, so this is going to be a discontinuous graph. So there's going to be a break in it at the y is equal to 0. Okay, so the graph shape should come down through each of these points. Now when you're drawing those, it's important to actually go through each of the points. We're heading off down to minus infinity down that way. We're going to go around the universe and kind of come back down from positive infinity back through our points here. Okay, it's a little bit like the reciprocal curve, but not quite, because you've got that minus 2x on the end. Okay, which gives it a bit more of a weird shape. Okay, so that's my graph. Curious. So yeah, that's a very strange looking graph. So use your graph to find the positive solution of 6 minus x minus 2x equal to 0. Well, y equals 0 is the x axis. So if you've got an equation set to 0, then you're looking at where it crosses the x-axis. Okay. Now we want the positive solution. Now noting that there is a negative solution here, isn't there? That's a negative solution because you've got a negative value of x, which is there, and then that's your positive solution there. So that one reads off to be about 1.7. So to one decimal place, then that's going to be 1.7. Okay. Question 8. The diagram shows a circle inside of a square of side 12 centimeters. Work out the percentage of the square that is shaded. You must show your working. Okay. Right, so first off, if we want to write this as a percentage of the total area, we need to find out what the total area of the square is. So total area of square to start with, that's the easy bit. Well, a square is just length times length, isn't it? It's going to be 12 squared, it's going to be 144. So if we're working out the percentage, then that's going to be the number on the bottom, isn't it? Okay, now we need to work out the number on the top. That's the slightly harder bit. So what is that kind of weird shaded part there? Okay, well, if you think about it, what you've got here is if I take my square and I divide it up into 4 quarters, like so, then what we've got is that in that shaded area is a quarter of the square subtract a quarter of the circle then, isn't it? And that's going to leave me with that shaded bit here. So if I take a quarter circle, if I take a quarter square and then I take off that quarter circle, I'm left with shady area. Okay, so quarter square, that's going to be, well, it's just going to be 144 over 4. Same thing as 6 squared, really, isn't it? So it's 36. Okay, and then we've got the quarter circle. That is going to be pi r squared over 4, where the radius is 6, isn't it? So that's going to be pi times 6 squared over 4. 36 over 4, that's 9, isn't it? So that's 9 pi. Okay, so then the shaded area is going to be the quarter square minus the quarter circle, which is 36 minus 9 pi. I'm just going to leave it as pi for now because I'm still going to do some more calculations with it. Right, so then, now I know the shaded area and I know the total area, so then I can work out the percentage shaded now. So percentage shaded, that's going to be shaded area over total area, which is going to be 36 minus 9 pi over 144. Yeah, so we found the total area of the square here was 144, and we found the shaded area to be that. So dividing one by the other, then we're going to get our answer, then, isn't it? Now this time I'm actually going to evaluate it. So I'm going to use the fraction key. I'm going to write the 36 minus 9 pi on the top of the fraction. And then 144 on the bottom. What does that give me? Apparently that's 0.0537 to 3 significant figures. What are we going for? I suppose to one decimal place. So I'm going to go for 0.054 then, I guess. That would be, when I convert that into percentage, that would be to 1 dp. So 0.054, which is 5.4% then. Question 9. The sides of a triangle are given in centimetres. The perimeter of the triangle is 80 centimetres. And I've been given a triangle here, and I can see all the sides are given as in algebraic form. Got x plus 5, 3x plus 1, 2x plus 8. Find the length of each side of the triangle. You must show your working. Okay, so that's just a matter of forming and solving an equation for the perimeter then, isn't it? So my perimeter is going to be equal to those three sides added together. So I've got x plus 5, I've got 3x plus 1, and I've got 2x plus 8. Okay, and I know that the perimeter is 80 because it gives me it in the question. So I can say that 80 is equal to, right, how many x's have I got? I've got an x, 3x, and 2x, which makes 6x. And I've got 5, 1, and 8, which adds up to 14. Okay, so I've got 80 equals 6x plus 14. So taking 14 away from both sides, that leaves me with 6x is equal to, what's that, 66? And then dividing through by 6, I'm going to get x is equal to 11 and 9. Okay, that's not really the answer though, but that allows us to find all the others, because if x is 11, then x plus 5 is 16, 3x would be 33 plus 1 is 34, and 2x would be 22 plus h is 30. So just double check, 30, 34, 64, and 16 is indeed 80. So that seems to work out. So there are my three sides. I'm going to get 16, 30, 34. Part B says, is the triangle above a right angle triangle? Use calculations to show how you decide. Okay, well, if it's a right angle triangle, then Pythagoras theorem will hold. Okay, it's a kind of the opposite way that we normally use Pythagoras theorem. We normally say, if it's a right angle triangle, then the square on the hypotenuse is equal to the sum of the squares of the other two sides. But here we're doing it the other way around. We're saying if the square on the hypotenuse is equal to the sum of the squares of the other two sides, then it must be a right angle triangle. So that's what we're going to do. We're going to see if Pythagoras theorem holds. Okay. Well, if it was a right angle triangle, then the 34 is going to be the hypotenuse, isn't it? Because that's the longest side there. So is 34 squared equal to the other two squared? 16 squared plus 30 squared. Is that true? Okay, well, let's find out. Is 16 squared 256 plus 30 squared 900, is that equal to 34 squared 1152? 1156. And yes, it is, isn't it? If you add those together, you are going to get a true statement. So that is true. So I'm going to say yes, it is. Yes, because the square on the hypotenuse is equal to the sum of the squares on the other two sides. I'm writing this out really long. You could probably just say because Pythagoras theorem, if you're going to be worrying. I just wrote down what Pythagoras theorem is. Yes, because the square on the hypotenuse is equal to the sum of the squares on the other two sides, and I'm probably just going to put in brackets 34 squared equals 16 squared plus 30 squared. Okay. Question 10. 100 people were asked whether they had visited France or Spain. 55 had visited France, 60 had visited Spain, 4 had not visited either country. Complete the Venn diagram. Right, so you have to be a little bit careful here because we don't know what the overlap is, okay, but we can easily find it. We can find it easily enough. Let's say the overlap between the two is X, then the number of people in the France only area is going to be 55 minus those people in the overlap, and the people in Spain who are Spain only are going to be 60 minus that overlap. And I know I've got 4 outside, and I know that all 4 of those zones needs to add up to the total number of people overall, which is 100. Okay, so given that the 4 things add up to 100, so 55 minus x plus 60 minus x plus 4 is equal to 100, then we could just form an equation x to solve then, can't we then? So 55, 60 and 4, what does that add up to? So that's 115, 119. So 119 minus x plus x minus x, so it's just minus x, is equal to 100. So rearranging that slightly, 119 minus 100 then is going to be equal to x. So x is equal to 19. So now I know that, then I know there's actually 19 in the middle section. 55 minus x is going to be 55 minus 19, which is going to be 36. And 60 minus x is going to be 41 then, isn't it? Okay. You might want to just double check that they all still add up to 100. So it's 36 plus 19 plus 41 plus 4. I believe it does. Yes, I think we're good there. So one of these 100 people is chosen at random. Write down the probability that this person has visited exactly one of the countries. Well, exactly one of the countries is going to be either France only, or it's going to be Spain only then, isn't it? It's going to be those two added together then. So the probability then is successful outcomes, 36 over 41. (36 plus 41 over 100). So 36 plus 41 is 77. So that's going to be 77 over 100. Okay, and then write down the probability that this person has visited France, given that they also visited Spain. Right, so this is what we call conditional probability. It means given that they also visited Spain, it means that we're only not now picking from all 100 students or people. We're just picking from those people who went to Spain. So how many people went to Spain in total? There were 60. So write down the probability that the person has visited France, given that they also visited Spain. So it's going to be only those 60 people, and the people in the Spain circle that also visited France is these 19 here then, isn't it? So it's going to be the 19 people who visited France who also visited Spain over the 60 people who visited Spain. So it's going to be 19 over 60. Question 11. You may use the coordinate grid to help you answer the following question. Describe fully the single transformation that is equivalent to a rotation of 180 degrees with centre 0, 1, followed by a translation of 4, 0. Okay, now we don't have to use we don't have to actually draw anything on the thing here. We just need to write the solution down, but it's going to be pretty difficult without actually just carrying it out, I think. We're going to carry it out and then we're going to look at what we've got and then describe what we've got. That's going to be the easiest way to answer it. So describe fully the single transformation that is equivalent to a rotation of 180 degrees with centre 0, 1. Let's do that first then. So a rotation of 180 degrees with centre 0, 1. So 0, 1 is here. That's going to be the centre of rotation. Now, if you're not very good at doing rotations, just put your hand up, ask for a sheet of tracing paper. Trace your triangle out. Put a cross through the centre of rotation and then turn it 2 quarter turns. You should find that your triangle ends up with points here, here and here. Okay, then removing your tracing paper, let's just join those together. So doink, doink, doink. So there's my triangle. Okay, and then once it's there, then we're going to translate it using the vector 4, 0, which is 4 to the right and 0 up. Okay, so each point is going to go 4 to the right. So this one here is going to go to here. So we're going to get one there, and one over there then. Okay. So again, just joining that up. Okay, got another triangle here. Okay, now you could do exactly the same thing with a rotation of 180 degrees if you just change the center of rotation. So if I move the center of rotation so it's still halfway between them, so where's halfway? It's like 2, 4, 6, 8, it's going to be 4. It's going to be here, isn't it? So if I move the center of rotation to this point, I could just do it with that single rotation of 180 degrees around that point. Okay, so I'm going to say I can do both of those moves in one move by using a rotation, 180 degrees, center, and then what's that, 2, 1? 2, 1. So that would do the same job, wouldn't it? Okay. Now you don't have to draw anything on the grid actually for this. Like I say, it's just really writing down rotation 180 degrees, center 2, 1. But how you'd work that out without drawing it, I don't know. Maybe you've got amazing spatial awareness. But for me, drawing it and then describing what I see is the best way forward. Question 12. Here are two functions. Function A, take your input, add 5 to it, multiply it by 3, and there's your output. And then function B, take your input, times it by 2, subtract 1, and there's your output. Okay, write an algebraic expression for the output of function A when its input is x. Okay, so if I take x and I feed it into this function machine, the first thing that's going to happen is I'm going to add 5 to it. I'm going to get x plus 5, and then I need to multiply it by 3. Now you need to take care, because if you just write times 3 on the end, BidMaths is going to let you down, isn't it? So actually what you're going to get is 3 lots of x plus 5. Now you must put the brackets in, otherwise you're not going to get the marks. Okay, so 3 lots of x plus 5. Part B says here's a composite function C. Function C is take the function A and then feed your results into function B, and then that will be your final output. So the input to function C is x, the output to function C is 2x plus 1. Find the value of x. You must show you're working. Okay. Right, so we've already written the first function. It's 3 lots of x plus 5. If we then fed that into the second function, we're going to get 3. So if I take 3 lots of x plus 5 and then I feed it into the second function, I'm going to times it by 2. So 3 times 2 is 6. I'm going to get 6 lots of x plus 5, and then I'm going to subtract 1 from that then, aren't I? Okay, so that is what I'm going to get. So I've got 6 lots of x plus 5 minus 1, and I know that the output in this particular case is 2x plus 1, so I can equate those two things. If I've got 6 lots of x plus 5 minus 1, and that's equal to 2x plus 1, solve for x. So I'm going to add 1 to both sides, and I'm going to multiply out the brackets. I'm going to modulate that in one go, because I can't bother to write twice. So moving the 1 over, I'm going to get 2x plus 2, and then multiplying out the brackets, I'm going to get 6x plus 30. So I've got 6x plus 30 equals 2x plus 2. Take 2x away from both sides, that's 4x, and take 30 away from both sides, I'm going to get 4x equals minus 28 then, aren't I? Okay, dividing through by 4, x equals minus 7. Okay, that's my value, x is minus 7. So minus 7 must have gone in. I add 5, I get negative 2. I times it by 3, I get negative 6. I times it by 2, I get negative 12. I subtract 1, I get negative 13, which is 2 lots of 7 minus 7 plus 1. That does work. Yeah. Question 13. Here are two pieces of work. Each shows a question and the first line of an incorrect solution. For each part, describe the error made in the first line of the solution. You do not need to complete the solution. For each part, describe the error made in the first part of the solution. Okay, so we've got some algebraic fractions here that we're adding together. So when you add fractions, you need to have a common denominator, don't you? So we're making a common denominator, and x minus 1, x plus 4 is the common denominator of those two, so that bit down there is fine. And then what you would do is, well, yeah, I can see what the error is there. So basically, this one here should be here, and this one here should be there. So they've got them the wrong way around. Okay, so what's happened there is, so the common denominator was formed correctly, but the numerator, I think it might be easier just to write down what the numerator should be. So the numerator should be 2 lots of x plus 4 plus 3 lots of x minus 1. That's probably quicker than just trying to describe how they got muddled up. Okay, it's only worth 1 mark, so probably just writing that down would have been enough. Right, so that's part A. Part B says solving x squared plus 7x plus 5 equals 0. The solution will be x is minus 7 plus or minus 7 squared minus 4 times 1 times 5 over 2 times 1. Well, if you remember, the quadratic solution should be x equals minus 7 plus or minus the root of b squared minus 4ac over 2a. Or minus a, I should say, if I'm just doing it algebraically. So I can see already what the problem is. It's here. This minus sign is in the wrong place. It should be negative 7, not negative all of that fraction. That's going to give you a different result. So I'm going to say that the negative symbol is in the wrong place. Should be, again, it's probably easy just to write down what it should be. Minus 7 plus or minus the root of 7 squared minus 4 times 1 times 5 all over 2 times 1. Okay, so that minus sign needs to be part of the numerator, not the whole fraction. Gosh, this is a wordy question. Question 14. A college offers 41 different subjects, including 9 different languages. Students are asked to choose 1 subject from option A and 1 subject from option B and 1 subject from option C. Each of the 41 different subjects appears only once, either in option A or in option B or in option C. Option A has 14 subjects, including 2 languages. Option B has 12 subjects, including 3 languages. Option C has 15 subjects, including 4 languages. Work out the proportion of all the possible subject combinations that include at least 1 language. You must show your work in. Gosh. Right, well, the total number of selections is easy enough to do. Total selections, it's just the 14 times the 12 times the 15. That will give you all the selections that it's possible to make. So you don't have, if you don't have to choose any language, or you can choose any number of languages, then you've got that number of choices. 14 times 12 times 15, which is equal to 14 times 12 times 15. That comes to 2,520. They're all the different possible combinations of those 3 subjects, or 3 subject selections. But work out the proportion of all the possible subject combinations include at least 1 language. Now, if you're picking at least 1 language, it's going to be pretty tricky to do. But sometimes it's easier to kind of flip things on their head. That can often be a lot easier. So rather than working out the number of combination with at least 1 language, I think instead I'm going to work out how many combinations there are with no languages, and if I take that away from the total selections that I found earlier, that should leave me with the ones with at least 1 language, because it could be 1, 2 or 3 then, couldn't it? Okay, so I think that's what I'm going to do. That should make the problem a whole lot easier. So let's work out selections with no languages. That's equal to well, it's going to be 14 minus 2. You've got 12 choices for the first one. 12 minus 3 is 9. And then you've got 15 minus 4 is going to be 11. So multiplying those together, 12 times 9 times 11, that gives us 1,188 selections with no languages. So therefore, selections with at least one language. Then going to be the total selections of 2520 minus the ones with none in, and that should leave you with the ones with at least a language in. So what's 2520 minus 1188? So 2520 minus 1188, that's 1332. 1332. So then what is the proportion of all possible subject combinations that include at least one language? Then the proportion then is going to be the 1332 that have at least one language in it over the 2520 total that we have. Does that cancel down at all? But write that as a fraction. 1332 over 2520, 37/70ths apparently. Yeah, so whenever you're looking at selection or probability and they have these things with at least one, you can often spin those around and look at none instead. That can often be an easier selection. That crops up in probability as well as selection, so it's a handy trick to know. Question 15. Y is inversely proportional to the square root of x. Y is 7 when x is 144. Find the value of y when x is equal to 16. Now, these proportionality questions are always given to you in 3 parts, and you need to work on each part in turn to get to the solution. Now, the first part is the relationship between the two values given here. The next part is the pair of values that go together given here. And then the final part gets you to use the complete equation to find a particular value. And that's there. Okay? Right, so we need to use each part in turn and kind of build together our equation. And once we've got it, then we can go on to the last part. So y is inversely proportional to the square root of x. Now, written down mathematically, y is proportional to 1 over the square root of x. Okay? So y, that's the symbol of proportionality. Y is proportional to 1 over the square root of x. Inversely proportional means 1 over. Now, that could be rewritten as an equation by replacing the symbol of inequality with equals k. So I get y equals k over root x. Okay, so that's it. That's what the yellow bit tells me. It tells me what the relationship is, and I can use that to form a partial equation. Okay, once I get to that point, then I need my two values that go together to kind of finish off the equation. So when y is equal to 7, x equals 144. So I've got two values now that I can plug into my expression, and then the only thing I won't know in it is k. So if 7 is equal to k divided by the square root of 144, plug in y is 7 and x is 144 in the right places than that. Then I just need to work out what that is and solve for k. Root 144 is 12, so times in both sides by 12, I'm going to get k is equal to 12 lots of 7, then, isn't it? What's 12 sevens? 84. Okay, so that comes from the green bit, and then once I know what k is, I can complete the equation. Therefore, the equation is y equals 84 over the root of x. Okay, so I used the green bit to sub into the equation, find k, and therefore complete the equation. Okay, once I've got the completed equation, I can then go on to the last part of the question, find the value of y when x is equal to 16. Okay, so what we're going to do now we've got the complete equation, we're going to plug x is equal to 16 into it, and we're going to finally find the value of y. So then y is going to be 84 divided by the root of 16. What's that? Well, root 16 is 4, and 4's into 84 go 21 times. So y is equal to 21, and then that is my solution. Okay? So when you're starting these equations, or when you're looking at these proportionality questions, don't be over fixated by the last part of the question, find the value of y when x is equal to 16. You've got a bit of work to do before you even get there. You've got to do all that forming of the equation first, using the information you've got. Only once you've got the equation should you try then to find the actual value that you're looking for. Okay? Yeah, so follow those 3 steps, it should be fairly straightforward. Y is 21. Question 16. If it rains on a given day, the probability that it will rain the next day is 0.65. If it does not rain on a given day, the probability that it will rain on the next day is 0.3. It rained on Monday. Complete the tree diagram. Okay, so the first part of our tree diagram is Tuesday, which means it definitely, and we're told it definitely rained on Monday. So for Tuesday, we're going to use the that it did rain on the previous day's scores, which is 0.65 then, isn't it? So if it rained on a given day, Monday it did, then the probability on Tuesday that it will rain the next day is 0.65. So then the 0.65 goes here. That means the probability that it doesn't rain on Tuesday is going to be 0.35, because these two numbers should add up to 1. Okay, and then given if it rained on Tuesday, then the probability is going to be the same on Wednesday, isn't it? It's going to be 0.65 because it rained on Tuesday, and 0.35 up here. Okay, but if it didn't rain on Tuesday, then the probability that it rains the next day is 0.3. So then that would be 0.3, and therefore the probability that it doesn't rain is 0.7. Okay, so we completed the tree diagram. Good job. Part B says find the probability that it rains on Wednesday. Probability that it rains on Wednesday. Okay, well the probability it rains on Wednesday is this route here, rain on Wednesday, or it's this route here, rain on Wednesday. Okay, so the probability that it rains on Wednesday is equal to the top root, probability of rain, plus probability of not rain. It's going to be those two added together. Now the probability of rain is that one there, look, and that is going to be those two numbers multiplied together. 0.65 times 0.65. What's that then? 0.65 times 0.65, or 0.65 squared. That's 0.4225. Okay, and then the probability of not rain, probability of not rain, that's going to be 0.35 times 0.3. What's that then? 0.35 times 0.3, that comes out to be 0.105. Okay, so then the probability then of rain on Wednesday is going to be those two added together. Then it's going to be 0.4225 plus 0.105, and that gives me 0.4225 added on, that's 0.5275. 0.5275. Okay. Question 17a. P, Q, and R are points on the circumference of a circle centre O. Angle PRQ is 59. Angle PQR is 67. Line SPT is a tangent to the circle. Work out angle A. Give a reason for your answer. Okay. Well, that's quite a nice, easy one to start off with, if you know your circle theorems. I've got a tangent here, SPT, and I've got a chord drawn at the point of contact. There, look, PR. And I've then got an angle subtended off that chord at Q. Okay, so what we've got here is the alternate segment theorem. And so this angle here, 67, and this angle here, A, are the same thing, because the alternate segment theorem says the angle between a tangent and a chord drawn at the point of contact is equal to the angle subtended in the alternate segment. Okay, so there we go, that's the answer. So A is 67. So A is 67, and the reason we can just say because of the alternate segment theorem. Okay, that's all we need to write down, the alternate segment theorem. Then part 2 says work out angle B, give a reason for your answer again. So where's B? B is here. Okay. Now, OP is a radius drawn at the point of contact with that tangent. So we should know that a tangent and the radius drawn at the point of contact always meet at a right angle. Okay, so OPS or OPT is a right angle. So I'm going to say, and if that is a right angle, then B and A must be a right angle between them, and so then B is going to be 90 take away A then, isn't it? Okay, so what's that? So 90 is equal to B plus A, which is equal to B plus, we said A was 67, so B then is equal to 90 take away 67, it's going to be 23. So angle B is 23 because the angle between a tangent and a radius is 90 degrees, so B equals 90 minus 67 equals 23. Okay, now for part B, we've got a different circle here. We've got E, F, G, H are points on the circumference of the circle centre O. Acute angle EHX equals X. Complete the following. Give the values of the angles in terms of X. Obtuse angle EOG. Obtuse angle EOG. That's going to be obtuse angle EOG. That's this one, isn't it? Okay. This one on the other side is a reflex angle, so they're not talking about that one. They're talking about that side. What's that one going to be? It's going to be well, it's going to be twice x, isn't it? It's going to be 2x because the angle at the center is twice the angle at the circumference. Okay, so you've got the angle subtended at the circumference is x, and the angle subtended off the same arc or chord is there, look, so that one is going to be twice as big as the one over there. Okay, standard circle theorem, that one. Therefore, reflex angle EOG is going to be, well, it's going to be 360 minus 2x, isn't it? Okay, and therefore angle EFG, where's EFG? EFG is going to be that one there, look. So therefore angle EFG is going to be half of that for the same reason. So this angle here, look, is going to be half this one for the same reason that x is half of 2x. So then EFG is going to be half of 360 minus 2x, which is going to be 180 minus x. And then write down what you're working in part B, part 1 is proved. So basically what we've got here then is I know that this one is x, and I know that this one is 180 minus x. So what we've proved is that opposite angles in a cyclic quadrilateral add up to 180. So opposite angles in a cyclic quadrilateral sum to 180, and I've got x and 180 minus x. Okay, they're my two angles, aren't they? Now I spotted that quite easy because I know this proof. You know, there are only so many proofs that can come up in the GCSE, so if you want to be totally prepared, know your proofs of your circle theorems. So that one's quite a common circle theorem proof, proving the cyclic quadrilateral by breaking it down into two lots of finding the center angle from the one at the circumference. Is fairly common. Okay, so yeah, it wasn't much of a surprise for me. Hopefully it isn't much of a surprise for you by the time the exam comes around. Question 18a. Show that the equation x cubed plus x squared minus 5 is equal to 0 has a solution between x equals 1 and x equals 2. Right, now I'm going to make a little table to do this because I'm going to have to do more than just that. I know it already because I know how these things go. So I'm going to make a little table ready to receive said values. Right, so first up, my value of x. So I'm going to try the values 1 and 2 in the equation x cubed plus x squared minus 5 and see what I get. So what do I get? X squared plus x. So if I've got 1 cubed plus 1 squared minus 5, what's that equal to? 1 cubed plus 1 squared is 2. Take away 5 is minus 3. Okay, so, and then my second one, if I try 2 cubed plus 2 squared minus 5, 2 cubed is 8, 2 squared is 4, 8 plus 4 is 12, take away 5 is 7. Okay, so were they equal to 0? No, this one was below, this one is above. Okay, so if one was below and one was above, then in between, sign change. So therefore it must, the solution must be between those two. So solution lies between x equals 1 and x equals 2. Okay, so we've kind of proved that first part. Then the next one, find the solution correct to one decimal place. So I know it lies between 1 and 2, so now I need to pin it between two numbers to 1dp. I'm just going to use the table function on the calculator to work this out for me. Otherwise I'm going to have to hunt for lots and lots of different values. Now I'm going to do this on the newest version of the Casio calculator. If you've got like the previous version, then I'll drop a link in the description which shows you how to do this on the earlier version, so you can go back and look at that video. Okay, but I'm going to use the new version. So what you need to do is you're going to press the home key and we're going to go into the table mode of the calculator. Right, then you should get like a little empty table appearing here. Now we need to fill that table with the values that we need. Right, so what we're going to do is we're going to press the option key, and first off we're going to define the range of what we're looking for. Now we're looking for the numbers between 1 and 2 going up in a step of 0.1. So our start value is 1, our end value is 2, and our step is 0.1. Okay, and then coming back to option again a second time, we're now going to put the function in, which is we're going to define f of x as being x cubed plus x squared minus 5. Okay, now once you've typed all that in, you should find that you get the table. Now part B says find the solution correct to one decimal place. You must show your calculations support your answer. Now scanning through the table of values, you can see from 1 up to 1.4 all the values are negative. And then at 1.5 up to 2, they're all positive. That means that the solution then must lie somewhere now between 1.4 and 1.5. So let's write those solutions down. So at 1.4, we know that it was minus 0.296 because the table told us so, which was below. And at 1.5 it is positive 625, which is above. Okay, so we know the solution is going to be either, we're going to either give the solution as 1.4 or 1.5. Now to decide which one of those two I'm going to give, the method is to test the midpoint of those two. I need to test 1.45 and see if it's below or above 0, and then I can decide which way I'm going to throw it. Okay, now the easiest way to do that is go one more time back to the tools and change the table range one more time. So this time I'm going to change the table range from starting at 1.4, going up to 1.5, and going up in steps of 0.05. Now when I press execute, you'll see then I get the answers 1.4, which I already had, 1.5, which I already had, but between them, more importantly, I've got 1.45, which I can see gives me the value of 0.1511. Now that is above 0, which means that the actual solution must lie between 1.4 and 1.45, and therefore 1.4 is going to be the closest solution to the result. So I'm going to give 1.4 down as my solution. Now this is a 4-mark question. You are not going to get those 4 marks unless you have tested 1.4, 1.5, 1.45, and then chosen 1.4 as your answer. Okay, so the way they award these marks is very, very regimented. So that is the way that you're going to get all the marks. Okay, pin it down between two numbers to one decimal place, which is what I did. I did 1.4 and 1.5. Test the midpoint of those, which is what I did. I tested 1.45. Decide which one of them you're going to give as your final answer. I gave 1.4. Okay? No other way to get all the marks. That is the way to get all the marks. Question 19. The graph shows the velocity of a particle over the first 20 minutes of its motion. Between 7 minutes and 15 minutes, the velocity of the particle is v meters per minute. The average velocity of the particle over the 20 minutes is 11.55 meters per minute. Find the value of v. You must show your working. Okay. Right, so we've been given the average velocity for the full 20 minutes here. So if we use the average velocity of that and that as the time, then we should be able to get the distance traveled, shouldn't we? Just using distance, speed, time. So ds t, so if the distance is the thing we want to find, the speed is 11.55 meters per minute, and the time is 20 minutes. Okay, what's the distance then? So covering up d there, distance equals speed times time then, isn't it? So distance equals speed times time, which is 11.55 times 20. So that means in those 20 minutes it would have travelled 11.55 times 20. It's going to have travelled 231 meters then, isn't it? Okay, so that is the total distance travelled. Okay, and that therefore is going to be the area under the velocity time graph, isn't it? Because the distance travelled is equal to the area under the velocity time graph. So we can use that fact then to work out v, I guess, because the area under the graph we can work out in terms of v, and then we can equate it with 231, and then we can solve for v. Should work, should work. So let's work it out then. What's the area of this one then? So area of a triangle is a half base height, isn't it? Which in this case, the base is 7, the height is v. So this one is going to be 7v over 2. Okay. This one is, well, it's just base times height, or length times width. That's the difference between 7 and 15. That's a base of 8 and a height of v. That one's just 8v. And then finally, this one is a triangle again. So that's half base height, which in this case is a half times the base, which is 5, times the height, which is v. So that's 5v over 2. Okay, so I know what all the individual areas are, and I know the sum of those areas is the distance. So I can equate those then, can't I? So if I've got the three areas, 7v over 2 plus 8v plus 5v over 2, and that is equal to 231. So what's that then? 7v over 2 plus 5v over 2 is 12v over 2, which is 6v. So 6v plus 8v, that is 14v. So 14v is equal to 231. So then v is going to be 231 over 14. What's that? 231 divided by 14. That's 16.5. So 16.5. So 16.5 what? Meters per minute, I guess. 16.5 meters per min. Okay. Does that feel about right? Well, remember the average speed was about 11.5, and it was only at the top speed of v for a part of that. So we're expecting v to be greater than 11.55 because it would have got up to that fast speed for a little bit, which would make up for some of the times it was going at a slower speed. Okay, yeah, so it looks decent. I think I'm happy with that. Let's move on. Question 20, the diagram shows triangle ABC. AB is 10.6, BC is 8.2, and AC is 12.5 centimeters. Show that the angle BAC is 40.5 degrees, correct to 1 decimal place. So angle BAC, that's the angle here, isn't it? Okay, so we've got a non-right angle triangle here. We know 3 sides and we want an angle. So what rule is that? Is that the sine rule or is it the cosine rule? Well, the cosine rule is about 3 sides. Either you know 3 sides, you want an angle, or you know 2 sides and an angle and you want the 3rd side. Okay? Sine rule is about opposite pairs, and we don't have 2 opposite pairs here, so it isn't the sine rule. So it's going to be the cosine rule. Let's state the cosine rule in terms of angle A. That is A squared equals B squared plus C squared minus 2BC cos A. Okay? And then it's just a matter of plugging those numbers in. No, it isn't. It's a matter of rearranging it so I can make cos A the subject. Let's do that first because we're finding the angle. So switching the 2BC cos A to the left and the A squared to the right, I'm going to get 2BC cos A is equal to B squared plus C squared minus A squared. You do need to practice this rearrangement because it comes up a lot. So cos A then is going to be B squared plus C squared minus A squared over 2BC. Okay, so now I've rearranged it in terms of cos A. I'm going to sub the numbers in. So B squared is, well, B is the side opposite. Angle B is 12.5. 12.5 squared plus C squared, that is the side opposite angle C, that's 10.6. 10.6 squared minus A squared. A is the side opposite A. It's going to be 8.2 over 2 lots of B, which was 12.5, over, so times by C, which was 10.6. Okay, so now it's just a matter for tapping it into the calculator carefully. So I'm going to use the fraction keys so I can write it down like it is on the page. So 12.5 squared plus 10.6 squared minus 8.2 squared all over 2 times 12.5 times 10.6. What's that then? That comes out to be 0.759. Just gonna round it off to 7599. Okay, but that's cos A, isn't it? We want A, so A then is going to be the inverse cosine of that number. Okay, so if I just press shift cos answer, I get an angle of 40.5 rounded off. So A is an angle of 40.5 degrees. Okay. So I know angle A now, it's 40.5 degrees. I want to work out the area of the triangle. Okay. So to find the area of the triangle, I'm going to use the trigonometric version of finding the area. So the area I'm going to be using is, well, I usually use half AB sine C, but I'm going to modulate it. So I've got A as the angle. So that would be half BC sine A then, written in terms of A. So it's going to be a half times B, half of B, which we knew was 12.5, times C, which we know is 10.6, times the sine of 40.5. I'm actually going to use the full calculator display that I've got. So I'm going to find the sine of my answer, and then I'm going to times it by those other things. So it's going to be 0.5 times 12.5 times 10.6 times the sine of my previous answer. That comes out to be 43.1. So that's 43.1. That's going to be my answer then, 43.1 centimeters squared. I believe we are done. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.